Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Friday, October 16th, 2020, our scheduled 41st day of school for the fall semester. We have reached a milestone date. Today is the last day of the first 9 weeks. Our first quarter of school, as of today, is over. Keep in mind, though, the dates could change on these videos for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. So let's take a look at what's happening today with our schedule. Today's due nows. No papers to pick up today. Yippee! Yesterday you picked up a new notes packet and a periods, groups, and electron configuration assignment, which mostly was review, I would hope. Wanted to let you know that I have finished grading your Unit 3-1 exams. They are in the grade book. The combined average in all three classes was right around 80, a little more than 80, which overall is really pretty good. This was a tough unit. Certainly some new material, some more advanced material, and so I'm pretty pleased with that. I expect the averages, the test averages in Chem 2 to be somewhat lower than they were for you guys in regular chemistry because this is more difficult material, as I think you probably realized after this last unit. But that's why you're here in the first place. Learn more chemistry than you got in regular chem so that you are ready for the next level, whatever that may be. So your homework for today was to complete the periods, groups, and electron configuration assignment. Don't turn it in yet. I told you that hopefully as you came in the door, as I'm going to go over it on the front board here for a few minutes, and then you can turn it in for a grade. We will briefly, emphasis on briefly, continue the Unit 3-2 notes packet in our study of the layout of the periodic table. I just want to show you some review of how it's laid out and maybe name some groups that you need to know. Some common names, I should say, of the groups that you would need to know. And then starting on Tuesday, we will get into periodic trends. Your binder is due today by the end of class. It's for a grade. Make sure you turn it in before the tardy bell today. The papers must be in order according to the list that you already have. And then finally, with today being the last day of the first quarter, Monday is our fall break day off, Monday the 19th. So enjoy your long weekend. Enjoy your fall day break off on Monday, and I will see you back here on Tuesday. So let's get to your assignment that was due today. Let me pull that up, and we'll talk about it in just a minute. So as a quick review, what we talked about yesterday, periods are the horizontal rows of the periodic table. They go from 1 to 7. Remember why? Well, they represent the energy levels, all right? Currently sitting at 1 to 7. Remember, for every element in a specific period or horizontal row, the outermost occupied energy level for electrons for any element in that period is equal to its period number, all right? So, having said that, let's look at period 4. So period 4 in the periodic table begins with the element potassium, right? 1, 2, 3, 4th one down, and ends with the element krypton. And again, as we just said, the reason it is called period 4 is that the outermost energy level in which electrons are found for every element in that period is the 4th energy level. So what I asked you to do here in number 2, for each of the elements in period 4, list how many protons are found in an atom and write the electron configuration. Regular way, not noble gas shortcut for each atom. So I briefly, again, the electron configuration should have been reviewed. But as a quick review, of course, the atomic number is going to tell you the number of protons and the number of electrons, which we base our electron configuration on. So potassium, that's 19. And if you, again, follow the diagonal rule, in order of the orbital filling, for potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, which puts it at its correct location on the periodic table. Its outermost occupied energy level, as you can see, is level 4. And if you scan down the rest of these, you're going to see the same thing. Now, when you get to scandium, Number 21. It ends with 3D1. Remember, we're starting the D block there as we run across to period 4 there in the middle. And so you see its last orbital is 3D1. However, it has 2 electrons in the 4s orbital, all right? And so, again, its outermost occupied energy level is level 4. And as you run your way across the D block there until you get on the next page to zinc, which is 3D10, again, we still have those 4s2 electrons there. So outermost energy level, level 4. And then, let me pull this up. As you continue across the P block, beginning with gallium and getting all the way to krypton, again, now we're after that 3D10 is full, we're filling the 4p. Again, we're back in the 4th energy level until we finally get to 4p6. So for every element in period 4, its outermost occupied energy level, where you're going to find electrons, is level 4. And the same is true for any period, all right, any horizontal row. Now, let's look at group 4a. So we finished up yesterday talking about groups. So there's 2 ways to label the groups. The new way is labeling 1 through 18, which I really don't care for because the old way really tells us something important. The old way is the S block and the P block. The representative elements are 1A, 2A, 3, 4, 5, 6, 7, and 8A. The center block, the D block, and of course the F block's found within them. Those are called the group B elements. I'll get to that in a little bit. Anyway, I like the old way because it tells us something about the elements in that group. So let's look at that. Group 4A in the periodic table begins with the element carbon and ends with the element flerovium. All right. The reason it's called group 4A, and here's the key, is because all of the elements in this group have 4 electrons in their outermost occupied energy level. And as we said yesterday, and you probably hopefully remember from Chem 1, those are called valence electrons, all right? Electrons found in the outermost occupied energy level. So let's take a look at this. So here, carbon number 6, 1s2, 2s2, 2p2. It ends with 2p2. You said, hey, there's 2 electrons. But look, 2s and 2p, those are its outermost energy level electrons, level 2. That's why it's in row 2, in period 2. But if you add those 2, the 2s2s and the 2p2s, that's a total of 4. You have 4 electrons in the outermost occupied energy level, which is level 2 for carbon, 4 valence electrons. When you go down to silicon, 3s2, 3p2, 4 electrons in energy level 3, its outermost. 4 valence electrons. When you get to germanium, now here's where you got to be careful. It ends up 4s2, 3d10, 4p2. But here again, the outermost energy level where electrons are is level 4. That's why it's in period 4. And you see 4s2, 4p2, again, total of 4. You'll see the same thing for tin, lead, and flerovium. 4 valence electrons, 4 electrons in that outermost occupied energy level. So that completes this assignment. Hope you understand it. Like I said, most of it should have been reviewed, but wanted to clarify specifically about periods and groups. So you'll be turning that assignment in for a grade, and then let's move on quickly just for some brief rehash of maybe some group names that maybe you remember, maybe you don't. So we'll pull up the notes here real quick. In fact, I don't think I am going to pull up the notes. I think I'm just going to pull up the periodic table. Well, I guess I did pull up the notes. I'm going to talk about some group names here that you need to remember. They're old family names. Remember, groups also are called families. So what's the significance of that? Well, in a family, you have people that are related, right? Well, in a group or a vertical column, you have elements that are related in their physical and chemical properties, and thus the old name family. Currently, though, they're called groups. Let's pull up your periodic table here. I want to talk to you about some special groups that you need to remember these names. So let's where are we here? There we are. All right, so remember we have 1A, 2A, and then over here 3A, 4A, 5A, 6A, 7A, and 8A. All right, so 1A are called the alkali metals. Hopefully you remember that. One thing I want to point out, hydrogen is not an alkali metal. Hydrogen is not a metal at all. It's a gas, of course. It has one electron only. We put it in group 1A because it does have one valence electron like 1A does, but it only has one electron, period. All right. So I just want you to understand, although hydrogen is in 1A, it is not an alkali metal. Absolutely not. All right. 2A are the alkaline earth metals. And then as we hop over here to 3A, no real special name here. This is called the aluminum group, 4A the carbon group, 5A the nitrogen group, 6A the oxygen group. You really don't need to know those. Those are really no big significance there. 7A, though, you need to know. These are called the halogens. Fluorine, chlorine, bromine, iodine, etc. And then, of course, 8A, I think you know, are the noble gases. Noble gases. There's some reading in the notes regarding these groups, the significance of the groups. You can read that on your own. You probably know most of that already, but certainly reading for you to do there to help maybe clear up some misconceptions or whatever, or add some more information for you there. The transition metals, the D block, are also called the group B elements. The 1A through 8A, the S block and the T block are called the representative elements. Skip that over, I think. Basically, that name comes from the fact that they represent the entire range of spectrum of properties, from metals to nonmetals, hence the word representative elements. They represent them all. The D block are called the group B elements, which also includes the intertransition metals. You know, they're found within the D block as well. And so these are, we call the transition metals. Of course, we've also called them the D block. And the F block are called the intertransition metals. Basically because they're found within the transition metals. That first row, the 4F row of the transition metals, are called the lanthanides because they begin with the element lanthanium. And the 5F row, the second row of the Fs, which begins with actinium, are thus called the actinides. So those are some names you should know. All right, those are some names you should know. Let's see. Maybe one other thing I would mention is that let's draw a vertical line here above boron. And then we're going to run it down boron and then across this way. I think you might recognize this. This little looks like a stair-step line. Basically, this separates the elements. A great majority of the elements are called metals, okay? And this much smaller area to the right, these are the non-metals. And in this particular area here, the stair-step line, or whatever you want to call it, the dividing line, most of the elements that border this line are called metalloids, right? And basically, metalloid means they share the properties of both metals and nonmetals. A couple things I would point out, though. Boron is a non-metal, and aluminum is a metal, all right? So boron's a non-metal, aluminum's a metal. But then as you work your way the rest of the way down, silicon and germanium are metalloids, arsenic and antimony, tellurium and polonium, and so on. When you get down here, tennessine or tennessine, which is a brand new element here in the recent years, it is technically a halogen, but with its being getting so far down here. We'll talk about that here in the coming days. All the halogens, of course, are non-metals, but these two basically are technically would be called metalloids. Certainly more non-metallic than metallic, but little gray area there. Okay, and of course the noble gases are all non-metals. So I think that's really all I wanted to cover today. We have a binder that's due by the end of the period. Hopefully you've already been working on that, but if not, give you some time to do that. Again, enjoy your fall break. We'll get going on this unit hot and heavy starting on Tuesday with the periodic trends and the formation of ions. We're going to spend the rest of our unit over those topics there. And also be reviewing some things we learned back in Unit 3.1. So until Tuesday, everybody enjoy your long weekend. Enjoy your fall break day off on Monday. It's been a good first 9 weeks so far. Happy about that. Happy about the progress we've made. Got a lot of work to do in the coming weeks, though, so stick with it, folks. Stay safe, everyone. Again, enjoy your long weekend. Take care, and I will see you on Tuesday. So long, everyone.